Hello dear students. So let us discuss about the calculation of crystal field stabilization energy of octahedral complexes. So in octahedral complexes we have two types. One is the high spin complexes and another one is the low spin complexes. So to calculate the crystal field stabilization energy in case of high spin complexes, so we have the formula, that is 0 minus 4 dq into n1 plus 6 dq into n2. So here the n1 is the number of electrons in the T2g orbitals and the n2 is the number of electrons in the Eg orbital. So for low spin complexes, the Cfse can be calculated by using the formula 0 minus n1 into minus 4 dq plus p plus n2 into 6 dq. So where p is called as the electron pairing energy. Okay, so by using these formulas, so we can calculate the crystal field stabilization energies. Okay, so let us consider an octahedral complex. Let us consider an octahedral complex containing 4 electrons in the d orbital. Okay, so that is, it is said to be a d4 system. Okay, so now there are two possibilities. So the 4 electrons present in the d orbital can occupy the T2g or Eg orbital. So here we have two possibilities. So the first possibility is that all the 4 electrons may occupy T2g orbital. In that T2g triply degenerate, so we have 3 orbitals. So these 4 electrons can occupy these 3 triply degenerate orbitals, and one electron obviously gets paired. Okay, so if all the 4 electrons occupies the T2g orbital, so then this will be the arrangement of electrons. So then how we can write the electronic configuration means, so if all the 4 electrons occupies the T2g orbital, then the electronic configuration can be written as T2g4. So this is the first possibility. Okay, so the second possibility is that the 3 electrons occupies T2g orbital, and one electron goes to the Eg orbital. Okay, so so here the 3 electrons, so in T2g, so we have 3 orbitals. In Eg, so we have 2 orbitals. So out of 4 electrons, if 3 electrons occupies the T2g orbital and 1 electron will occupy the Eg orbital. Okay, so now the electronic configuration so can be written as T2g3. There are 3 electrons in the T2g orbital, T2g3, and there is 1 electron in the Eg orbital. So therefore Eg1. So this is the second possibility. Okay, so the actual configuration may be decided based on the, that is, delta 0 value and also the pairing energy. So this is decided based on the two energies. So one is the pairing energy. Okay. So another one is delta G. So the pairing energy, it is nothing but the energy required to pair the electrons. Required to pair the electrons with one another is called as the pairing energy. Okay. So now these two electronic configurations can be decided based on the splitting energy. So that is delta naught and the pairing energy. Pairing energy P. Okay. So now let us see if the pairing energy is less than the splitting energy. Okay. So that means the electrons requires less amount of energy to get paired up than the splitting energy. Okay. So in the if the complex having the pairing energy smaller than the splitting energy, then the number of unpaired electrons are less. Unpaired electrons are less because the electrons will get paired up when the pairing energy is less. So the electrons will prefer to get paired up rather than split. Okay, rather than split into the two energy levels. So when the pairing energy is less than the splitting energy, so the electrons will prefer to get paired up. So therefore, when the electrons get paired up, unpaired electrons get paired up, so the number of unpaired electrons will be less. Okay, so when the unpaired electrons are less, so then such complexes are called as the low spin complexes. Low spin complexes. Okay, so when the pairing energy is less than the splitting energy, so these electrons will prefer this possibility number 1. Okay, so when pairing energy is less than the splitting energy, so the electrons try to get paired up. Okay, so they will follow the possibility number 1. So if pairing energy is greater than the splitting energy, okay, so the electrons requires more energy to get paired up. Okay, so when the pairing energy is greater than the splitting energy, so the unpaired electrons do not get paired up. Okay, so when the unpaired electrons do not get paired up, then the number of unpaired electrons will be more. Then the number of unpaired electrons will be more. So therefore, the complex is said to be a high spin complex. High spin complex. So then what happens if the pairing energy is greater than the splitting energy? So then the electrons will follow the possibility number 2. So that is, this electronic configuration will be followed by the electrons when the pairing energy is greater than the splitting energy. Okay, so now we can see, so what are low spin and high spin complexes? Okay, in any complex, if the pairing energy is less than the splitting energy, so then the complex will contain less number of electrons. Such complexes are called as the low spin complexes. So high spin complexes are those complexes in which the pairing energy is greater than the splitting energy and they contain more number of unpaired electrons. So such complexes are called as the high spin complexes. Okay, so let us take some examples. So let us calculate the crystal field stabilization energy in some complexes. Okay, so let us consider some examples here. So let us write number of d electrons in the complex. So next let us write the distribution of electrons. So distribution of electrons. So let us consider the high spin complexes. High spin complexes, and let us calculate the Cfse. So the Cfse for high spin complexes is given by, that is 0 minus 4 dq into n1 plus 6 dq into n2, 6 dq into n2. So let us calculate the crystal field stabilization energy for some of the complexes. If the number of d electrons is 1, okay, so then that system is called as a d1 system. Okay, so here let us write the distribution of the electrons. Okay, so that is T2g is number of electrons in the T2g orbital. So here you can write Eg. Eg is nothing but N2, number of electrons in the Eg orbitals. So here in T2g, so we have 3 orbitals. In Eg we have got 2 orbitals. Okay, so there is only one electron is present in the d orbital. So therefore obviously, so that electron will going to occupy the lower energy T2g orbital. Okay, so if you calculate the Cfse, you will get 4 dq. 4 dq. So let us take one more example. If the system contains 2 electrons, so then it is called as D2 system. D2 system. So 3 T2g orbitals and 2 Eg orbital. So now there are 2 electrons, there are 2 d electrons. So these d electrons will occupy the 2 T2g orbitals. Okay, so if you calculate the Cfs energy, so you will get 8 dq. 8 dq. So one more example let us consider. So if the system has 3 electrons, so it is called as the D3 system. So D3 system, it can be called as the D3 system. So we have got 3 orbitals in the T2g and 2 in the Eg. So these 3 electrons will going to occupy the 3 T2g lower energy orbitals. Okay, so if you calculate the Cfse, you will get 12 dq. Okay, so one more example let us consider. So 4 d electrons if present, so the system is said to be a d4 system. Okay, so d4 system. So now the 4 electrons, so previously we have discussed. Okay, so in case of high spin complexes, the pairing energy is greater than the splitting energy. Okay, so therefore what happens, instead of pairing, okay, so the d electrons will prefer to split. So let us see. So in case of high spin complexes, so how these electrons will get distributed. Okay, so there are 4 electrons in the d orbital. So this is a high spin complex. So in high spin complex, the pairing energy is greater than the splitting energy. So therefore these 4 electrons will not get paired up because the pairing energy is more. So therefore what happens? The out of 4 electrons, so the 3 electrons will occupy the lower energy T2g orbital and 1 electron will occupy the higher energy Eg orbital. Okay, so if you calculate the Cfse, so you will get 6 dq. 6 dq. So let us take one more example here. One more example. So if the number of d electrons is 5, it is said to be a d5 system. D5 system. Okay. So for a high spin complex, what happens? In case of high spin complexes, no pairing takes place. No pairing takes place. So therefore, out of 5 electrons, so the 3 electrons will occupy the lower energy T2g orbital and 2 electrons will going to occupy the higher energy Eg orbital. So therefore, the Cfse will be 0. Okay. So next, one more system. So that is 6 electrons. So that is D6 electronic configuration. Okay. So there are 6 electrons in the system and it is a high spin complex. So therefore the 6 electrons do not undergo pairing. So therefore the 3 electrons, first 3 electrons, what they will do? So they will occupy the lower energy Eg orbital and the 2 electrons will occupy the higher energy orbital. So then the remaining electron will get paired up in the lower energy T2g orbital. So if you calculate the Cfse, you will get 4 dq. Okay. So similarly, so let us calculate the Cfse for the low spin complexes. So for low spin complexes, let us calculate. Okay. So for low spin complexes, so the Cfse can be calculated by using the formula 0 minus n1 minus 4 dq plus pairing energy P plus n2 into 6 dq. Okay, so let us write it. So this is number of d electrons. Okay, so let us consider a d4 system. Okay, d4 system, because 1 2 3, what happens if you take d1 system or d2 or d3 system, so the electrons will going to occupy the lower energy T2g orbital, then there is no pairing. Okay, so the pairing occurs when the electrons present in the d orbital exceeds 3. Okay, so when the d orbital has the number of electrons equal to or greater than 4, then only the pairing will going to occur. Okay, so now in case of this, so this is T2g orbitals and this is Eg orbital. Okay, so this is low spin complex. In case of the low spin complex, so the pairing energy is less than the splitting energy. Okay, so the pairing energy is less than splitting energy. So therefore the electrons will prefer to get paired up rather than going to the higher energy Eg orbital. So here you can observe in D4 system, because the pairing energy is greater, so therefore the electrons without pairing, they will go to the higher energy state. So in this case, what happens? In case of low spin complexes, the pairing energy is less than the splitting energy. So therefore the electrons will prefer, when the pairing energy is less, so the electrons, the unpaired electrons will prefer to get paired up. Okay. So therefore, the 4 electrons, 1, 2, 3, 4. So instead of the electron going to the higher energy Eg orbital, it gets paired up. Okay, so if you calculate the Cfse, you will get 16 dq minus p. Okay, so similarly, if you calculate for d5 system, if 5 electrons are present in the d orbital means, so we have got the T2g and Eg orbital. So there are 5 electrons. So 1, 2, 3, 4 and 5. Okay, so 20 dq minus p. So if you calculate for the 6 electrons, d6 configuration, okay, d6 configuration, so 1, 2, 3, 4, 5. So there are 6 electrons, no pairing takes place. All the 6 electrons will going to occupy the lower energy T2g orbital. Okay, so it's a 24 dq minus p. Okay, similarly, let us consider one more example. 7 electrons, D7 system. D7 system. So that is 1, 2, 3, 4, 5, 7 electrons now. So first the electrons will get paired up. Okay, so when 6 electrons completely occupy the lower energy T2g orbital, then only the remaining 1 electron will go to the higher energy Eg orbital. So it's Cfse 18 dq minus p. Okay,